So for in this video, we're going to talk about a lot of examples about SAT level math 2, which belongs to the subjects test on the SAT problems. From today, my video will be divided into 3 or 2 questions, which means the first one can be the easiest and the second one can be the middle or the most difficult problem of each section in the SAT level math 2. In this case, let's start with the linear function problem. So the question is solve for the slope. So our question in this case will be solve for the slope of the line that is perpendicular to the linear function 3x minus 4y plus 8 is equal to 0 on the coordinate plane. So as we can see, our ultimate goal in this question will be solve for the slope. So let's get through this question and think about what are some of the things or some elements that we need to think about in order to approach and solve this question. So if we go back to the question and read it again, as we can see, there is a line on the coordinate plane. What should we think about if you think about the word line? As we can see on the coordinate plane, we'll think about the graph of the linear function. So this question is basically related to the linear function, but especially to the slope of our linear function. So let's think about firstly types and definition of functions with some properties of it or in it. The question is basically about our linear function. Let's think about the basic format of our linear function. Obviously, as we had talked about this in a lot of videos, it will be y is equal to mx plus n. Y is equal to mx plus n will be our linear function's basic form. Y is equal to mx plus n will be our basic, or we can call it as a standard form of our linear function. Now let's think about what does its variables. Now let's think about what does its variables or the constants affect to our original function, especially in our linear function, because this question is about our linear function. So as we can see, always in every single functions, we need to think about what is y and x. Y will be a specific output. Y will be a specific output. But what output? Output of our function. It can be either the quadratic or linear, rational, irrational functions output. Secondly, we need to think about what is our thing x beside m. Well, the x will be our input, unlike the first y, the input of our function. In this case, it will be the input in our linear function. And we can always think about y and x as our basic elements, which generates our quadratic or as well as the linear function. The reason is because we know that usually we note the function as f of x, and this is our function. And if you think about how it was, like the way it was generated, we know that we call y always f or y. So f is equal to our function y plus our input of our function, which we notated as the x. If we add it together, we notated this as f of x. F of x will be our function. That's why we call y and x the basic or the most important element when it comes to generating our function. And now it's time for us to think about other constants or variables which defines the difference between each functions. Firstly, let's think about what is m beside the x. What is m? Well, the m in our linear function, it will be a slope. It will be a slope of our linear function. And what is a slope? Slope is a thing that shows how steep the function lies on our coordinate plane. Well, the way to solve for this slope in a lot of ways, usually we notate it as the change in y, change in x, over change in y. This is a formula for solving for our slope. And usually, if you think about the formula to solve our slope, we're thinking about how the difference between a point will exist. And that we're going to generate our slope. And if you think about our formula, which is changing y over changing y a little bit specific, it will going to be y, so it's x2 minus x1, so x2 minus x1 over y2 minus y1. This is exactly the same thing with our changing y, changing x over changing y, because we're basically thinking about the difference between points in order to think about how steep the function is. From here, we can think about 2 points. Our 2 points, we call it first one A. Our first point will be x1 comma y1, and our second point B will be x2 comma y2. From here, we're thinking about our slope. That's why our formula x2 minus x1 over y2 minus y1 is a slope to solve for the difference between points. And from now on, let's think about the last one in our linear function element, which will be an. As we can see, n will be a constant, and if you don't know what the definition of a constant will be, the constant is exactly the same thing with the number. It is a number. The constant means it is a number without a variables beside it. That means the opposite word of a constant will be coefficient, which has the variables even though it's numbers. So basically n will be our y-intercept in our linear function. And let's think about the types of our intercepts in order to think about why the n value in our quadratic or linear functions will be our y-intercept. Well, as we know in a lot of videos, as we had talked about in a lot of videos, the word intercepts shows that the point, some specific point is on the specific axis. So there will be 2 cases since it's a point on the axis. The first case will be the x-intercept. Well, as we can see, the word intercept means there is a specific point on our axis, but the x-intercept will be the point on our x-axis. What is the point on our x-axis? It will be the time. It will be a case when our x value, which will going to be our specific input, where we input our specific values to our original function exists. And the only reason why we notate it as the x is because we know that the x value is our variable, which means changes depend on times. We can't just notate into a specific number. That's why we notate it as the x. The y-intercept will be when the x input exists, our output of our function will be 0. This is what the x-intercept will going to be. So this will going to be what the x-intercept will be. Let's think about the second type of our intercept. The second type of our intercept will be, what is our y-intercept? What is our y-intercept? Well, it is exactly the same kind of concept with the x-intercept, except the x input turns into 0 and the point. So the output of our function, which we notate as the y or f of x, will exist. And it's the same kind of reason why we notate as the y or output instead of specific number, because it is a variable, changes every times. So if you think about the 2 cases, the x-intercept and the y-intercept, there will be the types of our intercept in our functions. Second thing that we need to talk about when it comes to solving for the linear functions questions will be the graphs of its functions. And in the SAT level 2 maths, in the easy part of our function system, we only think about the two things. The first thing will be our quadratic function on our coordinate plane. So the first thing that we're going to talk about is a quadratic function, but not the important when it comes to solving this question. And the second function that we're going to talk about in the easy section of our SAT will be the linear function, which is the main focus in this question. And for the graph of our quadratic function, firstly, as we have talked about this in a lot of times, if you convert our quadratic function into a graph on the coordinate plane, it will going to be a specific parabola. It will going to be a specific parabola that satisfies our quadratic function. What about the linear function? Linear function, if you convert it into some specific graph, it will be a specific straight line that satisfies its equation that it contains. This will going to be its graphs in our quadratic and linear function. And there are two main things that is most important when it comes to solving this question. If we go back to our original question, it says perpendicular. When it comes to solving the SAT Maths Level 2 linear function system problems, they will gonna give us two main things if we say perpendicular or a parallel lines. There are two properties in our linear function that we need to think about in order to solve these questions. First thing is, what is the properties of perpendicular? And we know that for the perpendicular, it will look something like this. If there is a x and y axis, which we call it or sum of as the coordinate plane, there will be a y, which we call it as a horizontal line, and there will be an x-axis, which we notate as the vertical axis. There will be y and x. And let's imagine that there is a linear function which we notate as the straight line. For example, it will look something like this. And the perpendicular means, let's say perpendicular of this straight line, it will going to be like something like this. It will going to look something like this. That should satisfy our perpendicular line. And there's a stuff that we need to think about to describe the perpendicular and the parallel line. Whenever it is a perpendicular line, between lines there should always 90 degrees should always exist. So there will be 90 degrees like this. This will be our 90 degrees. This will also be our 90 degrees, which means there should be a right angle. This is what the perpendicular line means. So it always should be a 90 degrees. And for the property of our linear function when it comes to solving the perpendicular question, we think about perpendicular and as well as the parallel line, we always need to think about the slope, how steep the function is, and the y-intercept. So when it comes to describing or defining the difference between just a function and the perpendicular as well as the parallel line, we always need to think about it through our slope and the y-intercept in our linear functions to describe all of them. So for the perpendicular line, for this slope between two lines, for the perpendicular lines, the slope will be, let's say, our original function was y is equal to mx plus b. For the perpendicular line, if you just say that, if you assume that our y is equal to mx plus b, where our m is our slope of our linear function, and the b is equal to our y-intercept, in our linear function, we can define our perpendicular line in this way. The slope, we always need to think about in slopes and y-intercepts. The perpendicular line, so the perpendicular line with the linear function y is equal to mx plus b. So it should be y is equal to m, but instead of m, our property of our perpendicular line will be m to the -1 power, and then the y-intercept should always be exactly equal or equivalent. So if you write it again, our y should always be same because it is a thing that shares our common thing in our functions. Instead of m, we do m to the -1 power plus minus, and then our y-intercept will be exactly same. So if you actually convert what it means by the -1 power, so if you see that our original function was y is equal to mx plus b, our negative and the -1 power will be y is equal to, instead of m, -1 power means it is reversed, so it will going to be a reciprocal of it, so it will be 1 over m, and then we still contain our negative value to show that it is negative, and then we have our y-intercept positive b in this case. This is what the perpendicular line that we define in our linear function system. And the second thing that we need to think about is a parallel line. You can see for also the parallel line, it is exactly the same kind of concept with our perpendicular line. We always need to think about through our slope over a quadratic or the linear function. And also the second thing will be our y-intercept. The parallel line, if you draw it on our coordinate plane, let's say we have our coordinate plane that looks something like this. That contains our x, y coordinates, which we call it as the horizontal or the vertical lines on our coordinate plane. So this will be our x-axis, this will be our y-axis. And if we think about the parallel line, if you draw it two types, will look something like this. And in order to think about what it is to be a parallel line, if you make a straight line, it should always contain a right angle, like a perpendicular line. So we can think about something through here. If you think about, as we can see, it is a perpendicular or a parallel. That means the slope of each function should always be equivalent. But the only difference that makes these two lines different will be our y-intercept. The y-intercept will be different. And as we can see, it is different with the perpendicular line because the perpendicular line has the exactly same y-intercept, but the different slope. But for our parallel line, it has the same slope, but the different y-intercept that generates our parallel lines. So this will going to be what the parallel line will going to be. So our new function, and the new function will be y is equal to something we will call the negative m to the negative first power and negative x plus, instead of plus, it should be exactly the same y-intercept, which means minus 8 over 5. This will going to be our new function. And in this case, we're always trying to solve for a slope of a quadratic or the linear function in this case. And it should be a negative plus reciprocal. So if we solve for our slope, in this case, slope of our linear function will be 3 over 5. 3 over 5 will be our linear functions. It will be our linear functions slope. So if you think about the new function, this reciprocal and plus negative will be negative 3 over 5. 3 denominator, 5 in the numerator, because reciprocal means we're changing the directions or the positions of either denominator or denominator. This is what the changing the reciprocal means in our fractions. So all you have to do in this case is our new slope, or we can say an answer, will be -5/3. So if we write our full function, the full function, which will going to be our linear function in this case, will going to be y. We will call it as the g of x, not to be confused with our original function, is equal to our slope -5/3 plus our y-intercept, which should be exactly the same, which will going to be, in this case, -8/5. This will going to be our full linear functions that we need to consider in order to solve for this question. But our answer in this case will be -5/3. So this question was literally about solving for a perpendicular line, and in the same time we'll be solving the next question, which is about the parallel line.